Hello everyone, and thanks for watching Edupedia World videos. In this session of atomic structure, we'll look at the mathematical derivation or mathematical formulation of Bohr's atomic model. Okay, we have already seen the theory part of Bohr's atomic model. Okay, we have seen the postulates as given by the Bohr, and we have also tried to understand the meaning of those postulates. Alright, now we'll go into the depth of those postulates and we'll see the mathematics that comes out from there. Okay, so let's have a look at the atomic model of Bohr once again. Okay, we had a nucleus, okay, and we know that this nucleus is going to be positively charged. Alright, and we'll have circular orbits around those nucleus, and in those circular orbits we will have electrons revolving at constant speed, say v. Okay, so this is the velocity of electron, and we know that the radius will also be fixed. Okay, since the orbit's location is fixed, it will always be present at a radius or a distance r from the center of the nucleus. Okay, now we also know that this nucleus, alright, this nucleus will have protons in it. Okay, and if you remember atomic number, okay, atomic number, this term as represented by letter capital Z. Okay, if you remember atomic number Z, okay, represents the number of protons inside the nucleus. So if this is some random atom, okay, then it will have Z number of protons present inside it. Okay, which means the positive charge inside this blue colored nucleus is plus Ze. Okay, where E is the charge on 1 plus E is the charge on 1 proton, whose value is 1.6 into 10 to the power minus 19 coulomb. Similarly, the charge on this electron revolving will be minus E. Okay, that is magnitude will again be E, same as the charge on 1 proton, right? 1.6 into 10 to the power minus 19 coulomb. So nucleus, okay, you don't have to worry about the radius or the size of nucleus. Bohr assumed the nucleus to be point particles. Okay, at least for our derivation we'll take that. Okay, so now let's look at the analysis of forces involved over here. Okay, though your NCERT book, okay, as per the CBSE syllabus doesn't give this derivation, okay, but we'll look into it because it does talk about the radius and velocity. Okay, the textbook does talk about the radius and velocity, alright, and you also get questions on them in your exams. Okay, but in order to have a better understanding of radius and velocity and their values, and in order to memorize them, it is better to look at the derivation. Okay, so let's see if we can understand that. We know that the electron is in a circular motion. So any object in a circular motion has a centripetal force acting on it. Okay, so it has a centripetal force mv square by r acting towards the center. Okay, and this mv square by r, this force acts towards the center. Okay, this is the centripetal force Fc. Okay, so where is this centripetal force coming from? This centripetal force Fc is basically a result of electrostatic force between positive nucleus and negative electron. Okay, two unlike charges always attract each other. Okay, so this centripetal force is equal to mv square by r. This force is actually coming from, or is a result of, the electrostatic force of attraction. Okay, so what is the electrostatic force of attraction between, okay, between two oppositely charged particles? If this is say q1 and this is q2, alright, so whenever these two charges are present, there is an electrostatic force given by, whose magnitude is given by k q1 q2 divided by d square, where d is the distance between the centers of these two charged particles. Okay, now this expression of electrostatic force is something that you study in class 12th. Okay, that is another reason why this derivation is not taught to you right now. Okay, here k is a constant. Okay, you can just remember it as a universal constant. Let's not go into the value of that constant. Okay, though it is 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, q1 q2 will be the charges and d is the distance between the two charges. So in this case, in our case of the atom, okay, or in the Bohr's model, electrostatic force will be the force between the nucleus and between the electron revolving. So that will be equal to k into charge 1. Charge 1 is nucleus. What is the total charge on nucleus? It is z into e. Okay, let's just talk about the magnitude here, not signs, but the magnitude of charge inside the nucleus is z into e, where z is the number of protons or atomic number, and e is the charge on one single electron which is revolving. Okay, divided by distance between these two charges. The distance between these two charges is basically equal to the radius of the orbit, so divided by r square. Alright, so these are the two forces which are present over here. Basically there is one force, electrostatic force, which is providing the centripetal force. Alright, so let's derive this equation now. Okay, so we have the equation mv square by r is equal to k z e into e, that is e square divided by r square. Alright, now here k is a constant, okay, whose value is known to you. Okay, it is a universal constant. Okay, z is the atomic number of the particular atom. Okay, if you are making the derivation for hydrogen atom, for example, in your syllabus you mostly are concerned only with hydrogen atom, so z for hydrogen is always 1, for helium it is 2, for lithium it is 3, and so on. Okay, and E is the charge on the electron, 1.6 into 10 to the power minus 19 coulomb, and M here is mass of the electron. Okay, the centripetal force is acting on the electron, so this is mass of the electron. We are studying the motion of electron over here. So velocity v and r radius, these are the only two variables, rest all will be known to you. So if we have two variables, we need two different equations. So where does the second equation come from? The second equation will come from the quantization of angular momentum. If you remember, Bohr said that the angular momentum of this electron, that is mvr, is always going to be an integral multiple n of h by 2 pi, that is h cross. Okay, where n represents the orbit number of the electron, that is the orbit of which you are talking about. Okay, so now we have two equations and two variables. Here again h is known to us, n will be the orbit number, so it will be known to you, 2 is known to us, pi value is known to us, m is known to us. So v and r are variable here and v and r are variable here. So these two equations, if we solve these two equations, we can easily get the values of velocity and radius. Okay, and that is exactly what we are going to do over here. Okay, let's calculate radius value from the first equation. Okay, so r over here is k z e square divided by m v square. Okay, and simply substitute this r value into the second equation. So as soon as you do that, you substitute the r value in the second equation, you get m into v into k z e square divided by mv square is equal to n h by 2 pi. Okay, this is our h, Planck's constant h. Okay, so from here we have directly got the value of velocity v as 2 pi k e square divided by h into z divided by n. Okay, so this is the value of velocity of electron moving in orbit number n, okay, of an atom with atomic number z. Okay, if you like, you can remember this formula, though you don't need it for your school exams, but you will need it for any other competitive exams if you are going to appear for after your class 12th. Alright, so this is the velocity of electron. Alright, so velocity of electron, now we know the formula for it. Okay, it is 2 pi z. Okay, let's skip z here. Alright, and see that velocity is basically 2 pi k e square by h. Alright, and this into z by n. Okay, Why I have written it in this form? Because this part 2 pi k e square by h, okay, this part is actually a constant. Okay, we don't have to know the name of that constant, but this is going to be constant. Every variable here is basically actually a constant. Okay, so the velocity of any electron cannot depend on these values. It will only depend on the z value and the n value. Okay, and the numerical value of this constant comes out to be 2.18 into 10 to the power 6 meter per second. Okay, this is the value of this constant multiplied with z by n. Okay, so now if you want to calculate, say, for hydrogen atom, so if you want to calculate velocity for hydrogen atom, then we know that for hydrogen atom, okay, z is equal to 1. Alright, so you simply put here, instead of z you put 1, and now if you want to calculate the velocity of first orbit, then put n is equal to 1. If you want to calculate velocity of, say, third orbit, okay, in that case I'll put n is equal to 3, and I can calculate the velocity as v equals to 2.18 into 10 to the power 6 meter per second multiplied with 1 divided by 3. Similarly, you can also calculate velocity for, say, carbon atom. Okay, for carbon atom, okay, sorry, the velocity of electron present in the carbon atom. So let's assume that for now this is the nucleus and the electron is revolving in orbit number 5. Okay, so here n is equal to 5. So this means z for carbon atom is 6, and here since we are talking about the electron in 5th orbit, so velocity of electron comes out to be, okay, constant 2.18 into 10 to the power 6 multiplied with 6 divided by 5, and unit will be in SI, it will be meter per second. Alright, so this is the velocity. Now this expression of v that you got over here, v is equal to 2 pi k e square by h divided into z by n, you simply substitute this expression of velocity, okay, into our initial expression to get the radius of nth orbit. Okay, our initial expression mvr is equal to nh by 2 pi. Alright, so we know the value of velocity now. Okay, so if you simply substitute that value of velocity over here, you can get the value of radius. Okay, and if you do that, you will find that the expression for radius of the orbit, okay, so what is the distance of any particular orbit from the nucleus is h square, that is Planck's constant, divided by 4 pi square m k into e square. Alright, so this whole constant into n square by z. Okay, so here again this whole thing is a constant. Okay, every h, m, k and e present in this bracket is actually a constant, so this whole value will have a constant value, and the only variable here is going to be n and z, where n is the orbit number, okay, whose radius you want to calculate, and z will be the atomic number of the atom in which that orbit is present. Okay, so this constant is actually represented by a naught, small a, and with a subscript 0 with it. Okay, so this a naught into n square by z, this is the expression of radius. Okay, and now this expression you do have to remember even for your school exams right now. Alright, so a naught, okay, a naught is the constant, and this constant value is a naught is equal to 0.529 angstrom. Now this value also you have to remember. Okay, value of a naught is 0.529 angstrom, and if you remember 1 angstrom is, okay, 1 angstrom is 10 to the power minus 10 meter, right? Okay, if you like, sometimes it is also represented in form of picometer, so 52.9 picometer, and 1 picometer is, okay, it's quite obvious from here, it is 10 to the power minus 12 meter. Okay, so you have to remember this value of a naught, it is 0.529 angstrom. Okay, and if you know the conversion between angstrom and picometer and meter and nanometer, then you don't have to remember any other values. Okay, so if I have, say, hydrogen atom again, let's take hydrogen atom again. Okay, so I have an hydrogen atom, and in this hydrogen atom, let's talk about the first orbit. Okay, that is n is equal to 1, and since it is hydrogen atom, z is also equal to 1. So r comes out to be a naught multiplied with n square, which is 1 square, divided by z. Z is also 1, so r is equal to a naught. That is the radius of the first atom of our periodic table. Okay, and the radius of that first orbit of that first atom is equal to a naught. Okay, so this a naught is also called Bohr's radius. Okay, it has a separate name as Bohr's radius because Bohr actually conducted or gave his model for hydrogen atom, and hydrogen atom has an electron, only one electron in its first orbit. Okay, it has no electron in any other orbit. So this is basically the radius of the orbit in which electron of hydrogen atom generally revolves. So this a naught is called Bohr's radius, and that is why you also have to remember its value because it is quite important for us. Okay, so let's analyze this velocity and radius from somewhat abstract perspective. Okay, see, we have already seen that velocity, okay, velocity is basically a constant 2.18 into 10 to the power 6 into z divided by n. Okay, and we have also seen that radius is a naught into n square by z. Okay, so since 2.18 into 10 to the power 6 is a constant, from here I can say that velocity of an electron revolving in an atom is always proportional to z by n. Okay, so this relation you do have to remember. Okay, even right now, even for your school exams, that velocity of electron is directly proportional to z, that is the atomic number, and inversely proportional to n, that is the orbit number. Okay, and it is quite obvious. Okay, if you try to think of it in an abstract sense or in a qualitative manner, see, farther, okay, farther away the electron is, okay, the farther the electron is from the nucleus, okay, so it will need less value of energy, okay, at least in magnitude terms. All right, so if in magnitude terms it is having less energy, means it will have less velocity. Okay, basically kinetic energy, if you are talking about, it is half mv square. Okay, so that is one way of trying to understand this, that why velocity is inversely proportional to the orbit number. That is, the farther away I go from nucleus, lower will be the velocity of electron revolving. Okay, you can also think of it from this perspective. Okay, and a better way to explain this is that the electron is basically revolving, okay, due to the presence of electrostatic force, and this electrostatic force will keep on decreasing as we move further away from the nucleus. And if you keep on moving further away from the nucleus, the force is decreasing, which is a result of that same force will also have to decrease. Okay, and why is velocity directly proportional to z or the atomic number? Now that is a much easier and straightforward explanation, that greater the electrostatic force, okay, greater the electrostatic force, greater will be the velocity. And electrostatic force basically depends on the quantity or magnitude of the charges. Okay, and the charge inside the neutron, okay, sorry, the charge inside the nucleus is basically equal to Ze. So greater the atomic number, greater is the charge, and greater is the electrostatic force, and hence greater is the velocity. Okay, and greater the orbit number, lower is the electrostatic force, so lower is the velocity. Okay, so you have to remember that velocity is directly proportional to atomic number but inversely proportional to the orbit number. Similarly, if we look at the radius, then for radius we can say that r, okay, Now this is not V, this is R, which is directly proportional to n square divided by z. Okay. Now radius, now this you can think by yourself also. Okay, basically radius of the orbit depends on n square and z. Okay, and it is directly proportional to n square. That is, greater the orbit number, greater will be the value of radius. Okay, now that's quite obvious, right? If you move further away, okay, that is if you are moving to the higher orbit, say orbit number 11, then obviously the radius of 11th orbit will be greater than the radius of second orbit. Okay, similarly, if greater is the value of z, okay, greater is the value of z, then greater will be the electrostatic force. Okay, that is, greater the value of z, then greater is this charge on the nucleus. Okay, so greater will be the electrostatic force between the nucleus and electron, and hence if the force is higher, the electron will be closer to the nucleus. That means it will be present in an orbit which is more close to the nucleus. Okay, that is, it will be present at a lower value of radius. Okay, so remember that radius of the electron or the orbit decreases if the atomic number z increases. Okay, and the radius increases if the orbit number increases. Also remember that velocity decreases if the orbit number increases. Okay, and velocity increases if the atomic number increases. Okay, so this is all you have to remember over here. Okay, you don't have to remember the derivation for your school exams, but you do have to remember the value of a naught, and you do have to remember this proportionality expressions for velocity and radius. Okay, and it's better to have a clear understanding of this mathematical formulation. Okay, so in the next session we'll look at the energy calculations. Okay, and the mathematical formulation of energy of electron or the energy of orbit in Bohr's model. Okay. So until next time, and once again thanks for watching Edupedia World videos.